All right, welcome to the 2.6 to 2.10 review. We'll get going right away. So, first couple problems here. You're given quadratic equations, and each of them are in different forms. We have one in vertex form. We have one in standard form. And we have one in factored form. Okay, and each one has its pros and cons. So vertex form, that one is the one that just gives you the coordinates of the vertex inside the parentheses, outside the parentheses here. Inside the parentheses, we take the opposite. So my vertex is at +3, and outside the parentheses, it stays the same, -2. The other easy thing to spot with your vertex form is the stretch. And the stretch is the same thing as a multiplier. I'll come back and fill in everything else, but I'm just going to go through and pick out the easy stuff first. So with standard form, you only get the y-intercept, and that's your c value. Okay, so the y-intercept happens at x is equal to 0. Your y value is at 12. And we won't even be able to graph that. Our graph isn't even big enough. So won't be helpful to graph, but we can at least put that in for our y-intercept. And then again, your stretch, it's that first number, and there's nothing necessarily visible, but we think of it as 1x squared. If it was 0, then there wouldn't be an x squared. So it's 1x squared. Your stretch, your multiplier in this case, is 1. And with factored form is good for giving you the x-intercepts. Again, they're given to you inside the parentheses here, and it's 2 different points. But anytime something's inside the parentheses, I want you to think opposite. So our x-intercepts happen at +1, 0, and at -3, 0. So two different factors there, 2 different binomials. So we have 2 x-intercepts in that case. You could have 1 x-intercept, you could have 0 x-intercepts. And then our stretch, again, maybe not super intuitive, but this negative sign out front, that tells us our stretch, our multiplier is -1. And it also just makes sure you can kind of check your work, but it tells us that our parabola will be opening downwards, while all the rest were opening upwards because they had positive stretches. Oops. Okay. All right, so from here, let's fill out everything else. I'm going to go ahead with the vertex form number 1 here. Let's zoom in. Make this a little easier to read. I'll start by plotting the vertex. Again, it's at +3, -2, which would be right there. And just going down the line here, we need the axis of symmetry next. So that is our line that just goes right down the middle of the parabola and through our vertex. And your axis of symmetry always starts with x equals, and in this case, it's at +3. It will always match your x value of your vertex. Okay. And just so I don't forget my x equals, I'll go ahead and put that in on the rest as well. So it's already there. Okay. So it matches your vertex x value here. That's your axis of symmetry. X-intercepts. We can't see the x-intercepts at this point, but let's start building our graph. It's got a multiplier of 2. So I go out 1. Normally, if I'm thinking about my quadratic sequence, it goes 1, 4, 9, and so on. So normally we'd go out 1, up 1, but we need to multiply by 2, so we're going to go out 1, up 2. And when I go out 2 spaces, I'd normally go up 4, but with that multiplier, 4 times 2 is 8, 2, so out 2, 2, 4, 6, wait, did I count that right? 2, 4, 6, 8 is way up there. And then match it on the other side. And that's all I have room for. So there's my parabola. All right. And now we can see that our x-intercepts happen at +2 and +4. That's where it's crossing the x-axis. So +2, 0, and +4, 0. Our y-intercept, we can't see it on the graph. It's not big enough, so our graph space isn't big enough. There's a couple different ways to go about finding your y-axis. You could expand and distribute your vertex form and get it into standard form, get your y value that way. Or the way I would probably go about it is that we know that your y-intercept is along this line and your x value at that point is 0. So again, you could go through your y-intercepts and throw in that 0. Then it's just a fill in the blank thing. But we can put 0 in for x into our equation up here and then evaluate it and get our y value in that case. So that's what I'm going to do. I don't have a ton of space, but let's see if I can squeeze it right here. Y equals 2. I'm replacing x with 0. -3 squared minus 2. Okay, so to evaluate this, we start with parentheses. 0 minus 3 gives me -3. Still have everything else. 2 parentheses squared minus 2. Next order of operations would be to take care of the square, raising it to the second power. So -3 squared gives me +9. Bring everything else down. Okay, next order of operations we need to do is multiply. So 2 times 9 gives us 18. Bring everything else down. And y equals 18 minus 2 is 16. Okay, so our y-intercept is happening at 16, which makes sense as far as our graph goes. It's going up. You could also think of it this way. If I'm going out 3 spaces from my vertex, that gets me to the y-axis. And then we would just think through it. Okay, I'm going out 3. Normally I would go up 9. Then I multiply by 2, which gives me 18. And I just add 18 to that -2, and we get our 16 as well. Okay. Now we've got our standard form. Couple different ways you could go about this. You could factor and move it and get your x-intercepts and then work backwards from there. Or you could complete the square and get your vertex out of it. So since I have factored over with number 3, for number 2, I will complete the square just so you can see that. Completing the square, I throw in my parentheses around the x values with my space that I'm going to fill, plus 12. I'm going to take this value and divide it by 2. So that gives me, I'm going to put this down here, -4. This is starting to build my vertex form down here. So I'll square it. -4 squared gives me 16. 16 goes back up here. That's +16. I add 16 inside. I have to subtract 16 on the outside. 12 minus 16 is -4. That -4 gets brought down here. Point some arrows. And I didn't have an a term to worry about. So we have completed the square. We have our vertex form. Our vertex coordinates are then given with opposite, +4, stays the same, -4. Okay, and away we can go. So +4 and -4 is right here. We can start building our parabola, out 1, up 1. Again, we don't have any special multipliers to worry about, so we can just follow our regular quadratic sequence. Out 2, up 4, 2, 4. Out 3, up 9. That'd be up here. And that's all I'm going to have space for. Okay, there's my parabola. We can now see our x-intercepts. Our x-axis intercepts happens at 2 and 6. So writing that here, 2, 0, 6, 0. Last thing we need is our axis of symmetry. Kind of skipped over that, but again, it just goes right down the middle through your vertex. You don't have to necessarily draw it because it does match your vertex x value. That gets us 4. Okay, and we're done with number 2. Number 3. Again, we already have our factored form. We have our vertex, our x-intercepts. So let's plot those. We have a x-intercept at 1 and -3. Now we can start by finding our axis of symmetry by finding the halfway point between -3 and +1. There's 1, 2, 3, 4 spaces in between. Divide that by 2, we get 2. So down the middle of these guys is actually at -1. Remember I said that your vertex and your x value, your vertex x value and your axis of symmetry, they always match. So I know our vertex is at -1. I don't know where the y value is yet, but we do know that your vertex x value is at -1. So to find the y value, we can take that -1 and plug it in for x and evaluate. So what this will look like, I'll have a negative sign, -1, +3, parentheses, k. And I'm replacing my x value with -1 and evaluating. So -1, take care of our parentheses. -1 minus 1 is -2. -1 plus 3 is +2. Don't forget everything else. Bring all that down. So we have a -2, which turns it to a +2. And then +2 times +2 gives us +4. So our y value at this point is at 4. And it's right on that axis of symmetry. And it makes sense. If I go through my quadratic sequence, I go out 1. Normally I'd go up 1, but with that negative sign, I'll do the opposite. So I'll go down 1. If I go out 2, I normally go up 4, but with that negative sign, I'll go down 4. 1, 2, 3, 4. And that gets us right back to our x-intercepts where we started off. Okay. So we are done with that. And we can fill everything else out because we also happen to get our y-intercept while we were doing that. So our y-intercept happens at 5, 0, 5. All right, that's the first 3 problems. Moving down, we've got another 3. Similar idea, except all 3 of them are in standard form. Again, you can go about this however you want. First off, go ahead and make your lives easy and get your y-intercepts. Those are all at, well, not all of them, but this first one's at 0, -3. Second one is at 0, negative 4. Last one is at 0, positive 6. The other easy thing we can point out is our stretch. Okay, so we don't have anything out front here, so our stretch, our multiplier is just 1. Here, again, nothing out front, so we have a multiplier of 1. And for number 6, our stretch is 2. So those are the easy things to just be able to point out without doing any math. No math involved yet. From here, this is where you get to decide, do you want to complete the square? Come on. There we go. Do you want to complete the square and get your vertex form like we did for number 2? Or do you want to factor and come up with your x-intercepts and kind of work backwards from there like we did for 3? So it's up to you. Not everything is factorable. Some things are not nice to complete the square. So looking at this, number 5 would not be a good option to complete the square because you're going to be dealing with a fraction, right? We have to take that b term and divide it by 2. So this one I am going to choose to factor as long as factoring works, which looking at it with a negative 4, what times what gives you negative 4, but adds together to give you positive 3. That would be negative 4. Oops, nope, not negative 4. Positive 4 and negative 1. Okay, so I can factor that. That's what I'm going to do. Number 4, I'm looking at that. I've got an even number, so I'm going to go ahead and complete the square on that. And I'm also going to complete the square over here, just so you can see completing the square with that a term again. Complete the square. Complete. Oof. Sometimes the snap to shape thing is nice, other times it is not. Complete the square. Okay. So let's go with completing the square first. Number 4, I take that b term, I divide it by 2. This is going to start by giving me my vertex form. 2 divided by 2 is positive 1. Start filling out my vertex form there. Okay, then we need to work our way back up. 1 squared is still 1. We add it back in, but we have to subtract it. I skipped a step there. I didn't make my space, but negative 3 minus 1 gives me negative 4. Now we're in vertex form. Now we can finish this guy up. So vertex opposite inside the parentheses stays the same. That's outside. Negative 1, negative 4. My axis of symmetry matches the x value of the vertex. Don't know my x-intercepts, but let's plot this and see if it comes out. So negative 1, negative 4 is right here. We have a regular quadratic sequence with a stretch of 1. So over 1, up 1. Out 2, up 4. And that's really all I need to do because there's my x-intercepts. Our x-intercepts are at negative 3, 0, and positive 1, 0. All right, negative 3, positive 1. All right, we're done with 4. 5, I'm going to factor. I've already done a lot of the work here, but let's finish the factoring. So this puts this into this equation with our 2 sets of parentheses. We have a positive 4 and we have a negative 1. So now I'm in factored form. And again, remember anything inside of parentheses, think opposite. So our x-intercepts are at negative 4 and positive 1. Negative 4, 0, positive 1, 0. All right. From here, find the halfway point. It's 1, 2, 3, 4, 5 spaces. 1, 2, 3, 4, 5. That's kind of a pain, but we can deal with it. Halfway between there would be 2.5. So we kind of expected that anyway, because like I said, when I take 3 and divide it by 2, that's going to give me 1.5. So our axis of symmetry is at x equals negative, I'll go ahead and use decimals, 1.5. And therefore our vertex is at negative 1.5 for an x value. Don't know the y value, but what we'll do is work our way. Let's plug negative 1.5 in for x, and we'll solve from there. Okay, so negative 1.5, negative 1.5. That replaced x. Okay, we can go from here. So negative 1.5 plus 4 gives me 2.5. And negative 1.5 minus 1 gives me negative 2.5. Multiply those together, and we get negative. That would be 6.25. If I'm thinking about that right. Yes, that's my final answer. I'm going with it. Okay, so negative 6.25. That's down here somewhere. Okay. Negative 6.25. Now really, we've done everything we need to create this parabola. I've got 3 points on there. Maybe, I mean, if you want to go a little extra and do more, but there's my parabola. We filled in all the information. I'm happy honky-dory with that. Last one. Again, I'm going to complete the square on this, just so you can see with the a value. With your a value, I'll go through all my steps too. With your a value, we need to factor that out first. So factoring 2 out of 8x, we get 4x. We'll put our blank space in there, and then positive 6 on the outside. From here, we can go through our normal steps. Take the b term divided by 2. That gives us positive 2. We'll build our vertex form around that. Don't forget to bring this 2 down. 2 squared is 4. So that goes back in our space. And then we need to subtract it, but we need to multiply that 2 to the 4 first. So 2 times 4 is 8. So I'm going to subtract 8 from 6. That gets me negative 2. And so our vertex is opposite. Negative 2 stays the same. Negative 2. Put that right there. Our axis of symmetry matches your x value. Right down the middle. We do have a stretch of 2. So when I go to plot this, I go out 1, I go out up 1, but I need to multiply by 2. So out 1, up 2. Out 2, usually we go up 4, but we'll multiply by 8. So we go up to 6. Kind of a steep one. All right. We got our x-intercepts in that. Negative 3, negative 1. So negative 3, 0. Negative 1, 0. All right, and we are done with that page. Just to keep the videos from being huge, I'm going to stop the recording at this point. And I'll do another video for the second page.